In this video we have the integral of x over the square root of x plus 1. Now this seems to be a substitution. We could probably let u equal to the radical, the square root of x plus 1, and that probably will work. Or you can let it equal to just the radicand, x plus 1. I believe it'll work either way. The integral might not look exactly the same. There'll be some differences, but if you go ahead and check your answer, you'll find that it is one solution to this integral. So I'm going to let u equal to x plus 1. Then du would equal to the derivative of the right side will give me just 1, or dx. Got dx there. So notice I have a representation for x plus 1 here. That's going to be my u. I have a representation for dx in terms of the variable u. That'll be du. Can't have an x in the integral if I'm going to use a U-substitution. So from this expression here, solving that for x, x would equal to u minus 1. Taking the 1 over to the other side. Or adding a negative 1 to both sides. So then we come back over here and we're going to convert to the variable u. So x again is u minus 1 in the numerator. And the denominator we have x plus 1, the square root of x plus 1. So x plus 1, that'll be your u. And instead of a square root, I'm going to write this to the 1/2. So u to the 1/2 is the same thing as the square root of u. And then this will be dx will be replaced by du. And then we simplify, do the algebra here. This will be u over u to the 1/2, so we subtract the exponents. 1 minus 1/2 will give me u to the 1/2. And then 1 over u to the 1/2. Let's write it as, instead of 1 over u to the 1/2, write it as u to the negative 1/2. This will be du. And then we're going to integrate term by term here. Very basic integration here. We have u to the 1/2, so we add 1 to that. Give me u to the 3/2, and then divide the coefficient here by 1. Coefficient 1 by 3/2, this will give me 2/3. And the next one, add 1 to the minus 1/2 will give me a 1/2. And then divide the coefficient negative 1 by 1/2, this will give me a 2, minus 2. And then I've got the constant of integration here. And then all we have to do now is go back to the original variable here. So I got 2/3, and then the u is replaced by x plus 1. So I got 2/3, x plus 1, and then the exponent is 3/2. Then I've got a minus 2. Again, u to the 1/2 or the square root of u. I'm going to leave it as a fractional exponent here. So this will be x plus 1 for the u. And then to the negative, to the 1/2 power, plus c. And that's your answer. 2/3 x plus 1 to the 3/2 power minus 2. X plus 1 here to the 1/2 power plus the constant of integration. And whenever you have time just to practice your derivatives, you should check. So this is it for the video, but just to have some derivative practice here, we'll take the derivative, and when I show if I take the derivative of this, I'll get this integral, this integrand here. And keep in mind that I could rewrite this. I could factor x plus 1 to the 1/2 and bring it out and simplify. You'll see that in some textbooks. If you're taking a test where you don't really have time to do that, I don't think the instructor will count it wrong unless he tells you to write it as a product or something. But here we're just going to check this. So let's do this. See, 3/2, take the derivative of the first expression here. So 3/2 times 2/3 gives me 1. And then we subtract 1 from the exponent. And that'll give me a 1/2. And then don't forget the chain rule, even though here's not going to matter, because you take the derivative of x plus 1, it's going to be 1, and 1 times that, it's not going to change it. So you end up with that. And this one, The next term, 1/2 times the minus 2 is a minus 1 or just a minus. And then subtract 1 from the exponent. We get x plus 1 to the negative 1/2. So we got then x plus 1 to the 1/2. And then I'm going to rewrite the next one. Instead of the x plus 1 to negative 1/2, I'll bring that to the denominator. So this will be 1 over x plus 1 to the 1/2. And then I want to combine this. So I'm going to multiply, get a common denominator here. So I'm going to multiply over here by x plus 1 to the 1/2. So I have the same denominator, and then I'll multiply the top by also x plus 1 to the 1/2. And this will just become x plus 1 to the 1. Or simply x plus 1. You get this. So then I got the same denominator here. And that's x plus 1 to the 1/2. I'm just going to write that as the square root of x plus 1, just so it fits the original. So that's just the denominator written as a radical. And then in the numerator you got x plus 1 and minus 1. So the 1's cancel out. And that leaves you with an x, which is the same thing as this. So again, this is your answer. And this is just your check over here on the left side. Thanks for watching. We'll see you next time.